Hello everybody and welcome to today's second session. This session is dedicated to private networks. My name is Maria Matin-Mikko Blue and I come from the University of Oulu. It's my pleasure to welcome you to our session to hear what the three great panelists have to say about private networks. I will first give an overview of what this session will be about, and then we will hear the views of the participants. But you as the audience, you will have the opportunity to place questions to our great speakers. So just use the Q&A functionality in this webinar. Okay, so today's topic is private 5G and 6G networks as an ecosystem game changer. And what does that mean? Where did we get here? We have presentations from Nozomu Watanabe, Corporate Executive from NEC, Juho Pirskanen, Principal System Engineer from Wirepass, and Antonio Franzi, Head of Space for 5G and 6G Strategic Program at ESA, the European Space Agency. So as you can see already from here, we have a very versatile stakeholder group discussing today about private networks, not the traditional strong players of the mobile network connectivity business, but some different players. And you will have the opportunity to ask questions at the end. So I want to look back into the year 2017, 5 years ago, or even 6 years ago. I did this slide back then, and I was presenting these at different audiences, and the reception to that presentation was very different from where we are today. Finland had a national level research project about local private 5G mobile communication networks starting in 2016. And we were presenting this idea that in the future, there will be a large number of local mobile communication networks that could be deployed by very different stakeholders. There will be MNO deployments, wide area deployments, but there will also be local networks, local mobile communication networks that are dedicated to specific geographical areas. And those can then be deployed and operated by a variety of stakeholders. And back in that day, 5, 6 years ago, this was not at all the mainstream. This was very radical idea, very much different from what you could see in the research literature or what you could see in the forums, in the presentations of different forums. But there was already back then increasing interest about how to serve the variety of needs, area-specific needs, hospitals, harbors, industrial plants, and so on. And we took this opportunity and started to develop a local 5G micro-operator concept together with academia, industry, and regulator. And that always involves when you have wireless networks, when you have mobile communication networks, then the spectrum is the issue. You need to have access rights to spectrum, and there is a variety of ways how to do that. So we were looking into these local 5G micro-operators that could offer a variety of services, which is context specific. And then what are these networks actually, who are they serving? They can be closed networks, private networks to serve a closed, predefined user group. Actually, then they could be neutral hosts to serve MNO customers in some hotspot areas where it makes sense to build one network that serves the MNO customers. Or the same network could actually serve a variety of user groups with a variety of service levels. And that was the starting point, that you have local networks that serve different user groups. And when you have closed user groups, then you talk about private networks. And what has happened after that? They have become quite a popular deployment. What we're reading in the news all the time, private networks are taking place. And that involves different stakeholders. Factories themselves want to establish their networks. And at the same time, it still is an opportunity for the existing big players. MNOs themselves are talking about deploying private networks for their customers. And the user groups vary. And these private public networks, they operate under quite distinct regulatory conditions, regulatory regimes, which is influencing how to use those networks. And spectrum is the real bottleneck. How to enable this development you need to have the spectrum for that, and that has been treated quite differently in the different countries. Those decisions remain at the national level. Some countries have made it possible, like Finland, Germany, many other countries, but not all countries. So when we're looking at the deployments and situation in different countries, there is still very different situations out there. Then a few years ago, when we were looking into the 6G world, depicting the future 6G business ecosystem, we see that there are different end users, different resources, different combinations of resources that could be used to develop the services that are being used by the variety of end users. And these resource configurations, they are very different. You have a lot of different providers of the resources, and the complexity is increasing. But what we know already now is that this deployment mode that started in recent years will continue. We are moving towards this local operator paradigm to complement the wide area networks. And that is the topic of today's webinar. So where are we now, 6 years later, after the first ideas? There was so strong objection to those ideas that we were presenting back then. But nowadays it is happening in reality, and there are a lot of stakeholders seeing this as a business opportunity. So thank you. Next, I would like to move to our presentations. And the first presentation will be given by Nozomu Watanabe. He is corporate executive at NEC. Please, Nozomu, the floor is yours.
Okay, thank you. Let me just prepare my slide. Can you see my slide okay?
Yes.
Okay. Okay, so hello, my name is Nozomu Watanabe from NEC Corporation, and thank you very much for this opportunity, and I'm very pleased to take part in this session. So first, I would like to share our view on how we think that the world will look like in the beyond 5G or 6G era. And here are the three ideas NEC is envisioning. The first one is hyperreal communications transcending time and space. What this means is by connecting everything from human things and services in real time, we'll be able to remove any limitations or restrictions we usually have from time difference or space distance, and will bring us a new type of communications. The second one is expansion of digital twin. In the beyond 5G, 6G era, by utilizing the diversified sensing technologies and advanced analytics, we'll be able to project the real world, or even including the information which were not visible in the real world, to the virtual space. And by sharing, analyzing, and optimizing these in the virtual space, we can then provide appropriate feedback to the real world. And this is the cyber-physical communications loop for an augmented reality, as it is called digital twin. And the third one, seamless connection regardless of place, means that we can get the support from these environments at any time and anywhere. The world of beyond 5G, 6G is to realize such ideas. And NEC is calling the society realized by 6G as Tele-X society. In the future world of Tele-X society, we will be free from spatial constraints, and our presence is expected to expand all the way from the sea even to outer space. And we will also be able to overcome the constraints coming from the limit of human abilities. Furthermore, we will be able to relieve ourselves from time constraints and to be able to predict the future or experience something already happened in the past. The Tele-X society is our future, where we can make the most of our potential beyond human, beyond time, and beyond space. And this kind of next generation communications is our very goal of beyond 5G, 6G. So since this session is to talk about private network, I would like to briefly explain about the situation of private network in Japan. In Japan, government made a new regulation called Local 5G to enable private networks to meet the diverse requirement from enterprise public users and allocated some specific frequency bands for this purpose. Since then, we have increasing use cases using its additional characteristics of the private network as described on the right-hand side of this page. And local 5G is now expanding to various industries and contributing to the realization of the digital transformation to resolve social issues and accelerate industry development. To resolve the industry challenges, it is required not only to prepare network infrastructures that meet specific requirements, but also to provide comprehensive solutions from devices to application services. To deliver such vertical solutions, it is important to realize the values with a combination of internal assets and co-creations with partners. Collaboration to create an ecosystem with partners are one of the important key aspects. The prior expectation for today's 5G network is to boost the industries. And how will this change in the beyond 5G or 6G era? We believe that there will be a wider expectation for the values to realize a sustainable society where everyone can have the chance to reach their full potential even under the changing condition of the society, which requires new work styles and new lifestyles. Therefore, the networks in the beyond 5G, 6G era will be used not only to accelerate the industrial expansion, but also will need to provide the market values for a better society and for a brighter individual human daily life. In Japan, under the lead of Japanese government, Beyond 5G Promotion Consortium was formulated in 2020 to activate and accelerate the collaboration for Beyond 5G across industry, government, and academia. As one of the outcome of this consortium is this Beyond 5G white paper published in this March. The unique part of this white paper is that it includes the study assuming various usage scenarios and trends from many types of industries and daily life of users. At NEC, we are also taking actions towards 6G with various partners, including universities and other companies. Toward the 6G era, we have set some milestones as described here. Starting from the R&D activity in the lab, we are planning to set up a living laboratory, which is, for example, using the university campus to evaluate the feasibility of not only the technical aspect, but also the social implementation challenges, such as governance or rules and so on. Through these activities, we would like to collaborate with various partners and co-create an ecosystem with open innovations. Finally, to end my presentation, I would like to say that NEC has the will to realize a sustainable society where everyone has the chance to reach their full potential, and we will keep challenging to make innovation in the era of 5G and beyond. Thank you. Back to you, Maria.
Thank you very much for very interesting and inspiring presentation. Next, we move on to Juho Pirskanen from Wirepass. Juho, please go ahead.
Okay. Hello, everyone. You should see the slides and hear my voice, correct?
Yes.
Yes. Okay. So, well, I give a perhaps bit different view on private networks from our company point of view, and how we see the industry from our sector going forward. So, first few words about Wirepass. So, Wirepass is company concentrating to make a infinitely scalable connectivity software that doesn't fail, and concentrate on large industrial applications. We have been developing this non-cellular 5G standard, and we aim to be a winner in this kind of large-scale wireless market, which is the IoT. We believe that the number of IoT devices will be increasing heavily in coming years. And we are focusing on the software sales, and we have been doing more than our software has been supporting more than 300 different kind of products and several hundred partners in our company ecosystem. About the 5G private 5G non-cellular 5G, so the technology is based on this technology is this TEC-20, the new radio that was created by ETSI, and the design objective was to create a wireless communication technology which can be deployed by anyone and operated by anyone, anybody and anywhere, autonomous, simple, should be application agnostics for enabling digitalization, and we concentrate on developing and meeting those 5G requirements on massive type communication, massive type communication, and ultra reliable low latency communication. And after some evaluations, it was approved as part of 5G in I2R, and it's existing. And from what we currently see, we expect to see the first products during this year, and then larger commercialization during the next year. So it's existing, it's coming, and then when now looking different use cases, I will present some use cases that we see which are existing, but also some use cases that are and the use cases that are for TEC-2020 and this kind of private network use cases. So the first use case is smart meters, simply, and for the existing like deployments, one example, roughly 920,000 electricity meters connected to the single mesh network in Oslo area in Norway. No repeaters, no network infrastructure. One device out of 300 devices has the cellular modem as a backhaul, so it can be LTE or 5G, whatever is available. It's an example of private network. You can think about that it's a citywide private network controlled by the utility of the Oslo. So very large private network. Then you can think about smart lockers. You can find these in many places in Finland, for example. Basically every supermall, they are somewhere in the underground or in whatever place there is. You have a basically efficient real-time controlling of all the locks, no cabling, no need for energy except batteries for the locks, and you can improve your delivery of goods and also sending stuff by yourself, so customers can send packets through these lockers and receive packets, and they can be in many different locations. Simple extensibility, because you just when you need to have a new lockers or more lockers, you just add new lockers in the place. And it's an example of, again, a private network which can be deployed by anybody in anywhere in practice. Then another use case which could be which is emergency lighting. So existing deployments already in Kudosprang in Sydney, where over 2,500 upgrade emergency lines are controlled by wirelessly, and especially that the service provider knows exactly that all the lights are working, and they can have a site compliance constantly available. No need for checking that are the emergency lights working and so forth. And they are there, and it's an example of private network. And you can think about this kind of big arenas, a lot of people coming on, and it's extremely important that the emergency lights are working, and needs to be supported by the arena. But at the same time, when you think about the arena, of course there will be a concert as in the figure. So then we have other example of professional audio, which is a private network, extremely low latency communication. So basically the requirement to as fact that the sound is traveling directly from via bone and body and indirectly with the room reflections to the singer's mouth to ear. You have basically 4 millisecond turnaround latency from microphone to mixing desk and ear to ear monitoring device. So two-way communication below 2 milliseconds. And this is the use case, one of the use cases, early use cases we see for the DEC 2020 new radio for private network. And of course, as you think about, there's a private network of emergency lights in the arena, and then you have a private network of audio systems in the same arena in the same time. So multiple networks in the same location. Then smart city lighting, a slightly different use case. Energy and maintenance savings, significant. Quality of light provided to users, so how they are turned on, turned off, they are really working, not having. And you can think about the extreme amount of lights in big cities, and just the maintenance is a significant effort. And of course, here we are talking then, because the number of deployed lights are very high, the price of the infrastructure needs to be very low. So basically, the smart lighting infrastructure can be extended then to the other services also, but the light bulbs needs to be cheap so that they can be really deployed in high scale. Again, a private network example, citywide, or even large. And then, of course, the industrial sites, which can be combination of many things, industrial lighting solutions, asset material tracking solutions, machine condition monitoring solutions, real estate condition monitoring and security solutions. And this can be one or multiple networks. You can think about service providers providing lighting solutions, others having asset tracking solution, and then you have a security solution. And all those needs to work in the same area without compromising information security and compromising the performance of each of these networks. And they can be they must be sometimes be completely independent because of the business reasons and SLA reasons. But it's an example of private networks again in many areas. So in the summary, what we can see is that increasing the variety of different types of private networks is increasing. So it's not one type of network. There can be many different types of networks. This was just a glimpse of different examples that I presented here. So variety of those is increasing, and when we have a new communication solutions, this will just increase. There's no single type of private networks. So if we think about then the application variety also, so what we see currently is that this data amount is in this kind of MMTC massive type of power is increasing. Completely new use cases, new types of data, new data formats, security requirements are increasing. Over-the-air software updates are mandatory nowadays in this solution. So all in all, that increases the massive amount of data that this kind of sensors or IoT devices are producing and what they need to consume. Then also the classification between MMTs and URLCs, like imaging or blurring, in that sense that low amount of data, but fast response times are coming, control of robots, different kind of machines are coming. Perhaps there is a lot of variety in that kind of things, that what is the ultra reliable low latency in 5G, for example, 1 millisecond defined, whether there is actually 100 millisecond, but you have to get that data through in 100 millisecond, for example, or then the control the actions of the robots will stop, and that cannot happen. So there it's there's no clear division between the massive type communication and URLC. Then if we think about the promise of private networks for industry, so currently what we see is that 5% of machines are connected. If we can do the connectivity with 100 times lower cost, with 100 times less power consumption, and 100 times more density, so there's a lot of devices in the radio environment, we can connect 100% of machines and assets, so controlling different kind of warehouses and so forth. We can then provide information to critical value platforms and analytics and machine learning functionalities in the cloud or in the edge, wherever they are located. We can produce new level of productivity and sustainability for the industry. So, but it requires that the cost of connectivity goes radically down for IoT systems. So if we think about the current and future requirements as we are seeing currently, is that the access to the spectrum is the first requirement. Vast majority will use unlicensed spectrum or licensed exempt bands. Simply requesting or obtaining a license is too complex, too difficult, and too many places. You would need to do it in too many places. So dynamic spectrum sharing and coordination at the radio level is must in future. Then local licenses are needed on need basis. The simplicity and the cost of licensing process should be simple. Whatever is that measure, but it cannot be a very complex way of doing this. You might have support of multiple overlapping local licenses, so no like a single license, single location. That will not happen, and that will lead in at least some level of dynamic spectrum sharing and coordination at the radio level. So that at least we are visioning. Simplicity of the deployment, no network planning, no system configuration, avoid cabling needs, fitting existing building structures. So just simply, you are not, the business case or the possibilities of deploying things vanishes away if you need to start renovating your buildings. And then existing the IT infrastructure. So you need to be able to use the existing IT systems and so forth on the when you are connecting things to the systems. And basically operational sovereignty in that sense, that freedom to operate on select the best option for application and business cases. How do you store the data? Is it local cloud, service, public clouds, part of your existing IT structure or separate systems, internally managed or outsourced the private network? Security and data sharing solutions needs to be solved. Different data analytics and service solutions. But these all are different for different use cases, different business relations, different companies. There's no one way of doing this. Each company needs to be able to select their best. And then scaling the solution in terms of spectrum and technology. So when you have done some place or somewhere, it would be nice if you can use the same solution in the other place also. But if you need to geographically solve it every time differently, and it comes complex, then the whole IoT complex or the whole business case of connecting devices becomes more difficult. So as a summary, what we were doing, we were looking the new spectrum and how do we can do this and new technology option. And we were active on DEC20 new radio. We have dedicated licensed exempt band on at 1.9 gigahertz for this system. It supports dynamic spectrum sharing. It can support licensed spectrum if there is a licensed spectrum for the who is deploying mesh architecture without network planning can be deployed and integrated to by anyone and integrated to existing IoT system. And it's independent from system infrastructure, providing the sovereignty for the deployments, whoever is the deployer of the system. And then they can think about what is the best way of managing the system and the solution, whether it's outsourcing or managing by themselves or whatever system solution they would like to have. Okay, thank you.
Thank you, Juho. Very interesting presentation, clearly showing the different use cases for private networks as well as the different technology options that we have. If you stop sharing, and next we move on to our last presentation. It'll be given by Antonio Franci from the European Space Agency, and after that we will have the Q&A part, and I would like to encourage you to already now type your questions in the Q&A functionality so we can answer those later on. Antonio, please go ahead.
Thank you very much, Maria, and good morning, everybody. Thanks for inviting me to be part of this interesting 6G panel. As the last presenter of the panel, I would like to complement a little bit and add a new dimension to what already presented by my panelist colleagues. And I'd like to bring the dimension of space and discuss a little bit in a few minutes how space and space telecommunications can add value to the dialogue we're having in 5G, 6G, and mobile private network. Perhaps before I do that, just for those who might not be familiar with the European Space Agency, we are a European organization composed of 22 member states, including non-European countries like Canada, for example. And our mission is to support the competitiveness of the European and Canadian industry in space. So make sure that the space industry is well represented globally and can provide compelling solutions, for example, to the 5G and 6G dialogue. As the European Space Agency, we have launched more than 85 missions in space, and we operate across all space sectors, including Earth observation, navigation, telecommunication, human resource exploration, and anything to do with space. In terms of budget, we count roughly 6.5 billion euros per year, and that was the 2021 budget allocation, and some of it is focused on telecommunications. So if we dive in telecommunication in particular, we can see the impact of 5G, and that's the reason why we believe there is a global 5G and 6G economy, which is estimated by some reputable market research in the order of $13 trillion by the year 2035. That's the global economic impact that the 5G economy and 6G economy can bring. But that's predicated on the fact that, as mentioned before, that the communication and 5G is available ubiquitously everywhere, anywhere on the planet for anybody using it. We believe that space telecommunications, satellite telecommunications have a role to play in order to enable and unleash this 5G and 6G economy. In particular, we believe that of this 13 trillion, perhaps something like $500 billion could be attributable directly to the impact of 5G satellite telecommunications. So in a world where 5G is ubiquitous everywhere, the European Space Agency, having trouble seeing my screen. I'll just stop for a minute and I will share again. Can you see my screen correctly, Maria? Just to check. I can see something yes. on the top of yes. my screen. Okay, thank you. Okay, so then just moving on. It is for this reason that that we have created a new program called Space for 5G and 6G. And this is meant to support the large industry in Europe and Canada in order to develop solutions which are compelling for the 5G and 6G economy. The main strategic reason why we created this program are really underlined on the left-hand side of this slide. First and foremost, as we mentioned, is to support and underpin the 5G and 6G digital economy, make sure that 5G and 6G is globally aware and globally available for industry and society. As already mentioned by Nozomu-san, we want to improve everyday life, and something mentioned Society 5.0. We at ESA are also very much in support of societal benefit and improving everyday life on Earth by means of distributed digital connectivity, 5G and 6G. So that's one of the strategic reasons for ESA to intervene and provide funding to develop solutions which provide global ubiquitous connectivity. Finally, we want to inspire future generation. And what satellite can bring to the equation of 5G and 6G is seamless connectivity. Make sure that 5G and 6G is ubiquitously available everywhere globally, and is available in a resilient and secure and safe way, which is some of the requirements, some of the attributes required to deliver effectively 5G and 6G solution and applications, whether it's mobile private network or whether it's a public network or whether it's a hybrid network which makes use of space. And like the previous panelists, like Juho and Nozomu-san, I would like to focus perhaps on the applications and how space can add value to mobile private network and to applications in general. Some of them I already mentioned here. Perhaps what we see as relevant for space telecommunication, high space telecommunication can add value to terrestrial deployment of 5G, 6G, are in some of the main key market verticals already described, already touched upon during this panel. The first market vertical I'd like to mention is the huge market vertical of transport. Transport and mobility, whether transport is the transport on land, at sea, or in the air, we see that connectivity becomes more and more an essential element, not only connectivity, but connectivity available anywhere, anytime, and for anything. The proliferation of autonomous systems, and here the slide shows something like a maritime autonomous system, maritime autonomous ship in this case, requires very reliable connectivity in order to make sure that an autonomous ship is able to navigate, whether in port or out of port or in the ocean, and continuously allow the transmission, bidirectional transmission of data from ship to shore and vice versa, in order to guarantee the safety and security of the autonomous ships. Equally for aviation, there are a large proliferation of the connected aircraft and even autonomous aircraft, autonomous UAVs and so on, but also the large proliferation of in-flight connectivity and passenger connectivity requires perhaps to have 5G and mobile private networks in the aircraft and perhaps in the airports as well. And last but not least, connected autonomous vehicles and land transportation, high-speed trains requires very resilient and reliable communications in city, in rural areas, and in urban areas as well. And space telecommunication can add an element of coverage, resilience, and security, which is essential to allow the level of autonomously to continue to increase towards full autonomous of vehicles. On the right-hand side, it mentioned another interesting set of use cases, which is the transport and logistics value chain. Communications and 5G and 6G is transforming the value chain of the transport and logistics, and it allows goods to be tracked across various media, from land to sea to air, and from end to end, from the warehouse to the customer, so that the sensor connectivity set of devices allow to a tracking mechanism, allow to be preserve the integrity of the goods, but also allows to digitalize some of the processes which will improve the efficiency of these kind of transport logistics value chain and allow to introduce perhaps mobile private networks across media, across entity for people like ferry operators, insurance company, or end-to-end delivery system to run their own mobile private networks across radios, across media, and across geographies in order to control the end-to-end value of their business. Perhaps last but not least, I'd like to mention the digital health and the digitalization of healthcare. Already been mentioned before by some of my colleagues in the panel. The digitalization of the healthcare globally foresees a profound transformation of the e-health or medical care value chain, with the possibility to create a new model in this value chain to provide secure data to patient, to hospital, and to allow the decentralization of healthcare, moving the focus from the hospital to the house and allow people and patients to be treated more regional rather than centralizing in the hospital. All this new model, besides very secure data platforms, calls for ubiquitous connectivity. And this is where the combination of hybrid 3D space and terrestrial network 5G and 6G will be able to offer this kind of new model in area with where the deployment of terrestrial 5G and 6G might lag behind or might not be justified for from a business case point of view, and satellite can instead provide efficient communication in an integrated way. Perhaps just very quickly to dive into any of these use cases that we discussed before. I just took the example of the mining industry, the digital mining, taking advantage of a picture which kind of highlights, even in a relatively small niche vertical market like digital mining, there are a number of applications and use cases which require different attributes of 5G and 6G, including coverage. And this is typical of many, many use cases. So analyzing a digital mining set of use cases can actually be valid for many other use cases. You can see here from the picture that things like drones, UAVs utilized in the mining require resilient communication and beyond line of sight, sometimes communication served by satellite. Things like video surveillance and asset monitoring require a large broadband type of communication, which can be provided in a mobile private network type, but also connectivity for communication and field personnel across the mine is something which needs to be provided in a resilient way. And perhaps also what's worth noticing, already mentioned before, the connection between the digital world and the physical world, where even in a digital mine, there is a set of operations, functionality, and data which are stored online in the cloud, and perhaps digital twins operated on the cloud, which requires the continued transfer, bidirectional transfer of sensing data coming from the mine, and digital twin data, which perhaps sometimes predict or analyze or change some of the operations in the mine in order to respond to the data received. So all of this is kind of an example where a digital mine can be a use case of a mobile private network, and in an extended set of application will require MPN, which perhaps can be served by a combination of digital network, both terrestrial and satellite, as a unique MPN service offering. So coming to a conclusion of my presentation, I'd like to mention that all of this requires, of course, close coordination between mobile network operator, satellite network operators, and vertical market stakeholders, which might decide to operate their own mobile private network or might rely on a service offering, which is a combination of mobile network and satellite networks. And what at ESA, what we're doing besides supporting industry, the mobile network operator stakeholders or ecosystem, the satellite network operator ecosystem, and the vertical market ecosystem by and large across all the segments. We also develop our own living lab, which at the moment we have one implemented in the UK, in the ESA office in the UK, in a place called Harwell. And here we have a combination of indeed of hybrid networks, private and public 5G and satellite networks, where we invite industry to come and test their own applications or experiment their own models to validate some of the assumptions of operating public or mobile private networks in a range, in a combination of hybrid, space, and terrestrial 5G networks. I guess in a reasonable time, I will stop here. I'd just like to thank you very much all for the attention. And if anybody in the audience would like to follow up some of the interesting possibility of working with us in hybrid networks, you can email me at my email address or at our 5G inbox, which is 5g@esa.int. With this, I'd like to thank Maria, the panelist, and 6GSymposium for hosting me. And I wish everybody good continuation of the panel. And I'm ready, of course, to answer questions together with the panelists. So thank you very much.
Thank you, Antonio. Now we move on to our question and answer session, and we are inviting your questions through the Q&A function. And the first question is the following. We have seen that several operators are not willing to work with private networks just yet. What's the impact this scenario will have in the 5G, 6G marketplace? Is there a void for new companies to fill? Here I would like to first ask Nozomu-san to describe a little bit the situation in Japan, where this development is really progressing fast.
Mm-hmm. Well, yes. Well, for the like an enterprise user, there are so many use cases, and the network needs to be optimized for each specific purpose. And that may be why that it's a little bit difficult for mobile operator to cope with each requirement. And that's actually the main reason why this local 5G regulation was introduced, so that we can more easily create a localized network which is optimized for specific purpose. And yes, and that's will be the main reason for local mobile communication network will be more and more important in the future. But we will also, there's some good part of the public network. So we will probably see more and more cases where the local network interworking with public network. And by having such network, we will be able to provide more social values and help to realize that transformation to a new work style and lifestyle.
Thank you. And Juho, do you have experiences with this?
Well, as we see it is that let's say who owns the facility, who owns the use case, who is the investing to the devices and the systems. Many times is looking the capabilities just to deploy their own system and decouple the, let's say, this kind of infrastructure provider systems, and then sometimes they will integrate it. So of course the backhauls and so forth will be many and are many times used by cellular networks. But then we see that there needs to be a freedom for choice. So that's why we are looking like a free spectrum, simply spectrum availability under either non-licensed or unlicensed spectrum, or then this kind of local licensed spectrum. But that even the local license is quite difficult many times. So the license exempt bands are good and then you just deploy and you use your own business logics, business decisions. How do you want to cooperate with the cellular operators, who are your IT suppliers, and so forth.
Thank you. And Antonio, would you like to add?
I think for this question, I rely on my colleagues because I don't have any direct experience on this particular one. So thank you.
Great. Then there's another question, that how and under which conditions do the new business models for local 5G networks emerge? What are the most stringent challenges that private networks not deployed by the MNOs are facing? We already talked about one, and that was the spectrum. Juho, you might want to start.
Well, in the end, these new businesses needs to provide new value for the users and the companies. So there needs to be some value, and the cost of communication and how you distribute the value needs to be so that when you are like investing your own devices, own systems, your own IoT systems, of course the value needs to be coming mainly for yourself. If it goes somewhere else, then the motivation for doing that is not really there. The major value should come to who is generating the data and who is then owning the data and analyzing the data. And for factories and IoT systems, especially, it should come to those who are owning the business actually, where the data is connected.
Yeah. Nozomu-san.
Yes, well, the motivation for the end user to introduce private network would be to have a solution to solve their challenges that they are facing with, and therefore it will be very important to understand what their objectives are and work together on finding solutions to overcome those challenges and show how the network can be used for the solution. And this will require more close relationship with the end users. And since the solution will be more vertical and requires wide range of technologies and assets, it'll be also, more important to have a stronger collaboration with other partners from various domains. So I think we have to work on those to, expand the usage of the private networks.
Thank you. And Antonio.
Thank you, Maria. Yes, I agree with Nozomu-san. I think that it's a very interesting question, and there are three aspects which I think they've been kind of touched a little bit upon. One is the motivation, one is the ownership, and one is the constraints. And let me just perhaps add a little bit on these three aspects. The motivation, I agree, is to do with a better understanding of the requirements of that specific market sector. A mobile network operator or even satellite network operator might not understand very well the end-to-end requirement of those specific market. So there is a possibility for the emergence of specialized private network service provider, whether virtual or real service provider, which understand better the requirement, whether the requirement in terms of security or requirement in terms of perhaps multi-regional. In my case, I'm very interested in those mobile private networks which are geographically distributed across different territories, and that might change the requirements. In terms of ownership, sometimes the vertical market stakeholder might wish to own some of them themselves, the mobile network operator. They like to become themselves a kind of virtual network operator for their own business. One example I can bring is the ferry, end-to-end ferry logistics I mentioned before. In order to serve a global ferry market, you need to have access to all kind of different communication around the world, and it's much easier for the ferry operator or a service provider dedicated to the ferry operator to offer a global mobile private network to that ferry operator. And finally, on the I think on the constraints, indeed, spectrum remains the #1 constraint. And here, things mentioned like spectrum optimization, spectrum sharing or leasing, and coordination among different radio, terrestrial and satellite, including, needs to be addressed. So again, the collaboration of different network and service provider optimizing the constraints in terms of spectrum, for example, for a market is something that needs to be taken into account. So I think the combination of these three aspects make the role of MPN very important, and favors the emergence, perhaps, of new providers in this area, in this field.
Thank you, Antonio. Thank you, everybody. Thank you, audience, for your questions. Thank you, our speakers, for excellent presentation. I think it's now our time to end this dialogue. The topic of private networks the importance of that just keeps increasing, and I would be happy to revisit the situation 6 years from now. Thank you all, and have a great symposium.